Welcome back to Lecture 5. In this fourth and last segment, I'm going to give you a preview of a new system of logic called predicate logic. It's a system that uses predicates to express propositions. So let's use our running example, the one that involves dolphins, mammals, and flipper. And remember, the argument stated that S3 is a logical consequence of S1 and S2. Now here we're not interested in proving the validity of the argument. We're just trying to perform the first step of formalizing the argument. In other words, converting it to logic. Now we already made an attempt at this step in propositional logic, and remember that translation did not work at all. So in this segment, we're going to perform this step again, this time using predicates. So which predicates are we going to need? Well, we're going to need the predicate of being a dolphin. We need the property of being a mammal, the property of being a female, and these are the only three predicates we will need. Notice these are all unary predicates, so for each one of them we need to define one domain. So let's just say the domain of all of the variables associated with those three unary predicates is the set of all animals. And let's say that flipper is one element of this domain. It's one particular animal that we identify by name. Now we're ready to go ahead and convert these three sentences into predicate logic. So let's start with S3 and move our way up. S3 states that flipper is a mammal. Now, that's an atomic proposition. That's why in propositional logic, we translate it into a single propositional variable, P3. But now we are able to actually provide a little bit more detail about what that proposition states. It states that a specific object called flipper has a specific property, namely being a mammal. So we're going to be able to use the predicate M and apply it to the subject flipper. And the result is the proposition M of flipper. And that is the translation of S3 into predicate logic. And notice the difference between this proposition and this one, in that this proposition makes a distinction between the predicate and the subject of the sentence, whereas this proposition does not get at any of that internal structure of the sentence S3. So this is one advantage of predicate logic, to give us a little bit more information or detail about the internal structure of the sentences in terms of subjects and verbs. Now let's turn our attention to S2. Flipper is a female dolphin. Now we already performed some of the translation work when we looked at propositional logic. We already know that S2 ends up being a conjunction of two propositions. So this will remain the same. All we need to do now is to actually translate each proposition into predicate logic. So the first proposition, F, stands for flipper is a female. Well, in predicate logic, that becomes F of flipper, since F is a predicate for female. And the second operand of the conjunction, P2, actually stands for flipper is a dolphin. So in predicate logic, that becomes D of flipper, where D is the predicate for dolphin. So in conclusion, the translation into predicate logic of S2 is F of flipper and D of flipper. Make sure you understand this translation. And before we move on, let me make an important observation here. Remember how in propositional logic, one of the reasons why this translation was completely wrong is because there was no connection between any of these propositions. For example, notice there's nothing in common between S2 and S3. Well, that is not the case anymore. In fact, the whole point of this is to realize now that the subject of both S2 and S3 are the same, namely its flipper. Whereas this did not appear in propositional logic, it is obvious in predicate logic right here. Notice how flipper is the subject of all three of these predicates, and flipper appears both in S2 and S3. So that is a major advantage of predicate logic. Finally, let's focus on S1. S1 states that all dolphins are mammals. Now, even though it's not obvious, we had to work hard to realize that this statement is actually a conditional, which says that if something is a dolphin, then it's also a mammal. So let's put in the logical connective for the conditional, and let's work on the premise of that connective. So the premise is something is a dolphin. So we're going to use the predicate D for being a dolphin. But what are we going to use for the subject? What is the subject in something is a dolphin? Well, it's something. Since we don't know exactly what the subject is, we know there is one, but we don't know what it is, let's just use the variable x to denote it. So the premise of the conditional is simply represented as d of x, meaning x is a dolphin. So what can you infer if x is a dolphin? Well, you can infer that x is a mammal, and that is the conclusion of the conditional. So let's focus on that now. And we present the proposition x is a mammal using the predicate m and applying it to x. So in other words, the translation of S1 into predicate logic is the following. D of x implies m of x. In other words, if x is a dolphin, then x must be a mammal. In other words, all dolphins are mammals. So now it's pretty easy to see that this formalization of the argument is much better than this one. So let me emphasize that point again. You can see in this predicate logic set of expressions that now there's a connection between, say, S1 and S2. In particular, you notice that the predicate D for dolphin appears here and here, which of course is obvious in English, but was not the case at all in propositional logic, which is another reason why this translation was wrong. And so, not only does S1 now directly relate to S2, but even more importantly, S1 also has something in common with S3, namely the predicate mammal, which appears both here and here. So the conclusion here is that in this translation into predicate logic, it is at least possible or conceivable that S3 could be a logical consequence of S1 and S2, because at least S3 now is related to both S1 and S2. For example, S3 is related to S1 through the predicate M, and S3 is related to S2 through the object flipper. So we definitely made a lot of progress when we moved from from propositional logic to predicate logic. So here we are. We have a formal representation of the argument over here. So we are ready to proceed to step 2 and prove that the argument is valid, right? Wait, what is that? Please stop screaming. I can't understand what you're saying. Oh, wait, you're saying this is not correct? Oh, wait a second, you're right. This cannot possibly be correct. So for those of you who haven't screamed yet, please pause the video and figure out why this translation of S1, S2, and S3 cannot possibly be correct. So what is really wrong here is that this logical expression, d of x implies m of x, is not a proposition. So it cannot be a valid translation of S1. This is such an important point. I want to make a huge deal about it. Every single statement that appears in one of our arguments, and later on in the course, every single statement that appears in your proofs must be a proposition that's either true or false. Okay? So I hope everybody sees why this is not a proposition. Well, is it a declarative statement? Sure it is. D of x implies m of x. I'm not asking a question. I'm not giving an order. This is stating a fact that d of x implies m of x. But it must also have a truth value. And this does not have a truth value until and unless we know the specific value of x. X is a variable. So we don't know if d of x is true until we know what x is. We don't know if m of x is true, and even less whether the conditional is true. Now it's okay not to know if it's true. The question is, it doesn't even have a truth value. The truth value is not defined until and unless x is defined. So this doesn't have a truth value, therefore it's not a proposition, and therefore it cannot be a correct translation of this proposition. So what mistake did we make when we translated this sentence S1 into predicate logic like this? Well, we were partially correct, but we actually missed something quite important. So look at S1 and try to determine what's missing in this corresponding predicate logic expression. That's a pretty tough question, and that will be the topic of the next lecture. What's missing is called quantification. And one particular example of quantification is the use of the word all. So what this expression does not capture is the word all, that it should be true for all possible values of x. Notice when we translated S1, we said this means something is a dolphin. So we replace something with an x. But by doing so, we actually picked a particular element of the domain and we called it x. We say we don't know what it is, but it's one of the elements in the domain. But then what is wrong about that is that this statement is not a particular element in the domain, a particular dolphin or a particular mammal. It's true about all dolphins. So in other words, what's missing here is that this conditional is true for every possible element in the domain of x. That is called universal quantification. It's one of the two kinds of quantifications we're going to discuss later. And we will be done with predicate logic only after we discuss quantification. So that will be the topic of the next lecture.